I said on a globe model, you being on a certain point of it when it's tilted at a certain degree in a certain time of year and the sun not setting, that works. What they see, as I said earlier, makes, with the stars around you, it makes perfect sense to what they are observing.
Making sense doesn't make it true.
You just like literally.
Right, but I'm just asking you, how does it make sense if the Earth is flat then, and what place do I stand, and how does it make sense that I see this phenomenon where the sun just basically rotates around me quite low in the sky?
Because the sun isn't an object, dude.
Okay, what is it?
It isn't a ball. It isn't a ball of stuff, dude.
What is it?
Fuck if I know.
You don't know. No one knows, dude. Get in line. You want to know? Get in line.
And there's a reason why I say it's not a ball of stuff. Because when we take this model that predicts the 24-hour sun, right? And we say we actually try to use it in a three-dimensional way on a three-dimensional globe. The lines of sight to the sun don't intersect at a common location, and if you use it on a flat Earth, they also don't. And when I say don't intersect at a common location is, let's say I'm in Johannesburg, and I'm in frickin' Brussels, Belgium, and it's a certain time of day, we both decide to look at the sun, right? We see the sun in the sky at the same time, simultaneous time. I measure the azimuth and elevation angle. They measure their azimuth and elevation angle, and then we go, okay, let's map this. Let's model this onto the surface of the globe. Well, if you draw those lines of sight, they don't intersect in 3D space. Okay, so when I say, hey, the sun's not a physical objects, when more than one observer looks at them, their lines of sight intersect at the object. But the sun doesn't do this. Okay, and it doesn't even do it within the heliocentric model itself. This is what I'm talking about. The heliocentric model is a bunch of ad hoc shit. Because there's lots of observations that don't match, and people pretend they don't exist, or they don't know about them.
And I assume that those observations, assuming they do, because I've not seen these observations take place, and human error.
I mean, several people have done it, right? Several people have done this, right?
Error, right? It can always be a thing here.
Well, no, they use the model. They use the time and date. They use SunCalc, and then they get Blender or AutoCAD.
Using a model,
right? And they
doesn't eliminate human error. They take measurements themselves.
Well, no one observes the sun like that.
No, but anything where humans are taking measurements. I mean, are you saying that no measurements that have taken place does this model work, or in some does it not work? Because there's a big difference between the two. Because you would expect some measurements not to make sense, because human error is always an element in any.
I'm talking about if they take SunCalc or time and date, which is what frickin' the final experiment used to predict whether they'd see a 24-hour sun or not. They use these models. You take them and you model them to the globe. Sun is not in a common location. Meaning, right. there's a unique sun for each observer that you would map to the surface of a globe.
So if you was to get,
it has a unique position.
Yeah, so if you're on person A there, and let's call the other one person B, and then you get on a plane, and then you fly west to person B, and you go fast enough so that you see that, like, does it not remain the same sun all the way around? Like, it's just very confusing how you almost say.
I don't know.
You can do that. Like,
I don't know if anyone's ever done that shit. Chase the sun.
I mean, you put back and get on a flight from California to Australia and effectively chase the sun. Like, you can be on the sunlight for the entire of that flight.
I don't know how any of what you just said addresses what I said.
Because everything that I'm saying works on a globe model, like the 24-hour sun. The fact that you say these measurements don't work. I mean, firstly, like I don't know the sources of this.
Don't work? Time and date and SunCalc.
Yeah. Okay, so you
those are websites, right?
Two different
and you can go on there, and you can take any place on Earth at any time, and it'll give you a value. Azimuth, elevation. Elevation would be how high is it above the horizon. Azimuth is it's the direction to north. So you can take this value and you can put it on a globe, right? A 3D model of a globe. Boom. And then you can take another one, second observer. Boom. And then you can take that angle. That's the direction the sun is supposed to be from that observer location. And extend the line out forever. And then you can take the other second observers and extend the line out forever. And see if those lines cross each other at some location. They don't. That's what I'm trying to tell you. And they don't cross at 93 million miles. They don't cross at fucking 125 miles. They don't cross.
How when you do this every single time, like, are they completely off, or are they just by a little bit?
Some have ended up behind the person.
Behind, so like 180 degrees off.
Yeah, so like if you follow the lines, they're actually divergent, right? The viewpoints are divergent. So like when you join the lines converge behind the observer. On the other side of the globe, behind them. So they're looking at the sun, but the sun is triangulating to behind them, which makes no sense.
Yeah, of course it makes no sense. I would be really curious to see anything in more detail.
Okay, so I can give you another example. But a very specific one.
We stick on that example. That's really interesting, though.
Well, it's just the same thing, but like you can easily check this yourself. You can go on time and date, 2 locations, Tierra del Fuego in Chile, right? And
Chile, so I can't check it. There's no sun here.
Well, whatever, when at your convenience or never. Right. So Tierra del Fuego in Chile, Ushuaia, Ushuaia and Tierra del Fuego, Chile or Peru, wherever or Argentina, whatever the fuck it is down there. So that location. Now this is gonna be for the equinox, right? And we want another location on the same line of longitude, and because we want a simultaneous sunrise, and we're gonna get the direction of the sunrise. What direction does the sun rise?
East.
From these 2 locations, right? On the equinox, how many degrees?
Oh,
so you do Connaught, Greenland, and Ushuaia, right? And if you look at the values, what direction the sunrise? In Ushuaia, the sun will rise at 91 degrees.
Right.
Okay, that's so 1 degree more than due east. Yeah. In Greenland, it'll rise at 86 degrees. So tell me, how can they both be looking at the sun, but they're looking in different directions?
Wait, so someone in the northern hemisphere is looking 86 degrees. Someone in the southern hemisphere is looking 91 degrees.
Yeah.
How do those? I mean, firstly, I don't know.
Those lines of sight don't converge.
Yeah, because one seems to go slightly north and one seems to go slightly south, right? That's the
point. Yeah.
But what are those measurements from? You've just given me 2 numbers. I don't know like a source of it.
Well, the values you can go on time and date.
Okay. Can
time and date.com.
To this out of interest?
Yeah, I probably even got one, but probably from a couple of years ago. I mean, a link right to the. Okay.
Hello, Robert Utah just randomly messaged me and said, "Can't take down the spherical Earth, buddy. All flat Earths are doing is running up and down in blood pressure."
Be running up and down Jacob's ladder? That would be more fitting.
Okay, dude.
I'm trying to crack a screenshot, man. Okay, and here's another thing, a topic with the sun. And it's going to seem obscure, but in 1597...
Right, you're linking this to the date, but like I said, let's just concentrate on what you said there, where, it would be Greenland at 86 degrees and Chile at 91 degrees.
Yeah, just go to the equinox date and look at the angle that the sun rises for each of those locations. I'm not going to do all, like, how fucking spoon-fed do you need to be?
No, that's okay. Now you've said that, right? I get what you're saying.
Anyway, so Barents in 1597, his ship was stuck in the Arctic, and it was the equinox, and the sun was supposed to rise, but it had already risen 2 weeks before that. And it rose every day in those 2 weeks before the equinox. And they knew where they were, because they used celestial navigation, so they knew exactly where they were. But the sun rose 2 weeks too early. You have lots of instances like this. Like when they've actually examined and tested the accuracy of sunrise predictions and sunsets, they tested at 3 observatories, and the mean error is 5 minutes. And with some of the values are 14 minutes off. So when people say works perfectly, I have to call bullshit, dude. It don't work perfectly. It works good enough for practical purposes, and that's it.
I
And if
can't
the
say
sun doesn't rise, and if the sun doesn't rise within fucking 15 minutes of when it was supposed to, no one calls the National Guard and says, "Oh my God, call the president. Something's wrong with the sun. It rose 15 minutes too late."
I don't know of any time that's happened though. I mean, I very occasionally.
I told you they studied it. I can find the paper if you really want. Where they actually measured the sunrises, right? So they said, here's the prediction of when the sun's supposed to rise based upon our models. Let's go actually do the observation and see if it matches the model.
Yeah, interesting.
The mean error, the mean value, the average value of the average precision of the model versus the observation was plus or minus 5 minutes. Now, I'm sure you've heard people say they predict eclipses down to the second. Well, how's that possible when they can't even predict sunrises to the minute? In the largest measured values they had was the sun rose something like 14 minutes too early, which is a large amount. That is a significant amount. See, this is what I'm talking about. This is an example. Like, how did we even get here, right? So always got to review. How did we get here? We got here because I said, hey, we went and checked. I don't know about everybody else. I went and checked.
Rock refraction. That's why, Indio. Come on.
Obviously refraction. When in doubt, refraction is like it's like you know how you got your secondary parachute. When you jump out of an airplane, you got 2 parachutes. The backup chute. Refraction is like a backup chute. Fuck, I'm cooked. Pull the backup chute. My fucking chute wasn't open. Here, I'll try and find that sunrise paper. And if you go to like the U.S. Naval Observatory's website, they have a litigation section because often they're asked like for court cases like they need like sunrise and sunset times for some case, and they want like quote unquote authoritative value of what it was. And what it says is no agency of the United States government observes sunrise and sunset times. The times can be calculated to sufficient precision that are good enough for all practical purposes. That's what they say on their website. So they don't say it's 100% accurate. No one claims that. Only freaking goofball goers on the internet.
Oh, that's so good. That is a good one. You can imagine so many instances where someone, like you said once, to hear from an authoritative source as evidence.
Yeah, dude, it's like it's not true unless they have a freaking shiny badge or something. It's freaking really weird. I mean, I was just brought up different or something. I was brought up like, it's doesn't matter who says it, it's what they say. That's where the truth is.
True. 2 + 2 is 4. Doesn't matter who says it. Unless it's a flat earther, of course. If they say it, they're wrong.
Yeah, automatically wrong. And not just wrong, we're going to freaking call you names because you're so.
Okay. But while I get that the answers to this seem to come down to atmospheric refraction, which you're saying is ad hoc, even though that's, from what I know, something that's been understood for a while, right? But you're saying that's ad hoc, no?
Actually, it is ad hoc.
Okay. But there is no answer for any of both of those phenomena with the flat Earth model, right?
Well, I can tell you why it's ad hoc, because there's other things you would see with refraction that we don't see, right? So refraction is just not like this one-off phenomenon that just like moves shit up or down. And we know this because we design lenses, right?
But it specifically takes place in the lower atmosphere. But
there's other. Yeah. I know the story, but we should see other visual phenomenon other than things being moved around. It just doesn't displace things in space, right? Make things appear up higher or lower. Yeah, you get distortion. You get something called chromatic aberration.
Yeah,
meaning the colors of it will turn into a rainbow, right? So it'll appear more blue on blue on top and more red on the bottom, because you're actually seeing a double image of the object, and not a double image in the sense of like an inferior or superior mirage. A double image as a blue image. You're seeing a blue image and a red image superimposed on each other, but they're displaced a little bit spatially because the blue light takes a different path than the red light. That's what happens when there's refraction. That's how a prism works. So if there's like this crazy extreme refraction, in the case of baryons, it said it's on like 4 degrees, dude, you would literally, so we see it, they compensate for it in astronomy. Just for some reason, there's no compensation terrestrially, even though it's the same thing, even though you're looking through, arguably a worse condition. But nobody has dispersion correctors on their freaking, 400 millimeter zoom freaking cameras, zoom lenses, to take a picture across like some large distance to correct for chromatic aberration. You know what they actually do? They actually do the reverse of this. They use epichromatic lenses, which correct at the lens to make sure the lens doesn't cause any chromatic aberration. But if the lens doesn't, that means whatever is out there in the air will be even more visible.
But the lens is a sharp boundary between those two medians, right?
What do you mean?
So the lens, So it's but whereas the atmosphere doesn't have that, it's like a gradual density, and the gradient changes slowly.
Doesn't matter. That would make it even worse.
Would it? That's not from my understanding.
Yeah, the longer the optical path, the greater the spatial separation is going to be, because it has more distance to do it in.
No, because an initial sharp change in boundary would result in the largest change, right?
No, it's continuous. It doesn't just stop. It's not just at the boundary where it happens. It happens through the entire medium. Refraction depends on the wavelength of the electromagnetic radiation. So blue light and red light will take a different path. In the medium itself, it's just not on entry. Yeah, but it's not just on exit. It's not like, I know you're thinking of a prism, shining the white light at the prism, and you see, when it leaves the prism, you see the rainbow. But it's actually being separated inside the prism.
Yeah, I mean, firstly,
it's not happening when it leaves; it's happening inside.
No, we're talking about a very minimal change here, for example, as well. Like, we're not talking about the amount of refraction that you see with a prism, because that's a large angle change.
Well, they see it in astronomy. They make something called a dispersion corrector for telescopes.
Yeah. I mean, you would, because when you're talking about something that's that far away, surely you're going to have to make some correction there to get anything that attempts to be accurate. But the sun is, orders of magnitude.
What do you mean? That far away? Is it being refracted in space?
No, it's being refracted through the atmosphere, but with the accuracy, when you're talking of multiple orders of magnitude further away, that astronomical of other suns and stuff are from our sun. Yeah. I would imagine that would be the reason why they have some science there to adjust to that.
But when you're looking horizontally across the surface of the Earth, that's where the greatest temperature gradient is, right at the surface.
What Indio's explaining is, for practical reasons, when people shoot long range, and these observations have been recorded, you can find them on YouTube. There are multiple effects, multiple temperatures, multiple temperatures, humidity zones over the distance of the shot, including multiple directions of air movement, which also affect things as the bullet is traveling, and all they can do is make their best estimate. It's dynamic.
And when you say we expect to see some diffraction, we do see some diffraction. Like a sun rising is perfect.
Dispersion, not diffraction, dispersion.
Okay,
we should see. What I'm trying to tell you is, if there is a significant refraction present in the air, you will observe dispersion. Period. It can't be avoided. This isn't like an option.
Right, but when you look at the sun, you said you would expect, just to stick on this 1 second, you said you would expect to see some distortion with the light, due to this atmospheric effect.
Dispersion, yes.
Mediums.
Dispersion, yes. We don't see it.
But you do. I mean, that's not a perfect sun. That's distorted.
I'm not talking about distortion. I'm talking about dispersion, the separation of the colors of the white light.
Yeah. And again, there's some separation of the colors, but it's minimal between the two. Like it's so minimal because it's over such a small amount of distance.
You've seen the separation of the colors of the sun. You've seen a blue sun on top and freaking red sun on the bottom.
I said it's minimal. It is red on the bottom and it's white on the top. Like it's a minimal distortion.
Yeah, which demonstrates there's no refraction, dude. You don't understand, dude. The more refraction you claim, the more dispersion there has to be. It has to exist.
Right.
They are intrinsically linked to each other. So the more there's a refractive gradient, right? So there's a gradient of refractive index. The more of this there is, the greater the separation are going to be of the colors. Because each one takes a different path. Dude, in anything, refraction itself depends on the wavelength.
But what I'm saying here is it's a very small amount. So in a very small amount of refraction, you get complete separation between the colors, right? That's from my.
Well, a very small amount of refraction. Yes, exactly. If there's a large amount of refraction, less dispersion. Or if there's a low amount of refraction, you'd have little dispersion. If you have a large amount of refraction, there'd be less dispersion. But all these observations we have where we hear, well, there was extreme refraction in that case, there's no corresponding dispersion to it.
But
that's why it's ad hoc. I'm trying to tell you, to start it with, you asked me, it's ad hoc. You'll say it's ad hoc. I said, yeah. And this is the reason it's ad hoc, because there's no actual evidence for it. Right? It's ad hoc to stop the globe from being falsified. It's like, oh shit, if this observation is geometrically correct, it's falsified. Oh, let's have an ad hoc hypothesis that saves the previous hypothesis from being falsified. But without the evidence, corresponding evidence. It's not like they found refraction evidence first, and then we're like, let's apply it to this globe we measured. It's like, we know it's a globe. This observation would show it's not a globe. How can we explain this away with some phenomenon? We'll just say the phenomenon we know that's light. Let's say it's refraction bending the light and flattening everything out. That's what makes it ad hoc, because there's no corresponding other evidence.
Okay, so
but we know this other corresponding evidence does exist in nature because of astronomically we observe it.
Yeah, I don't quite think the two.
No one's ever taken a picture of a red blue mountain, dude. Sorry, it's never happened. But they have taken red blue Saturn pictures, red blue star pictures, red blue fucking sun pictures. I don't know about the sun. I don't think the sun has. The sun might wash it out, so it might not be visible.
Okay, so you're saying we see those refractions within other planetary bodies, but we don't within earthly bodies that are here like a mountain, because it goes through such a small amount.
What I'm saying is, for astronomical objects, we do observe this effect, the dispersion effect. Not necessarily the sun. I don't think I've ever seen it with the moon, but I've seen it with Saturn, Jupiter, stars, right? They make something called a dispersion corrector, where you basically turn a mirror and it'll merge the double image. So what it does is the light comes into the telescope. Inside it splits the image into two images, right? And then those images, you have a mirror, and it's reflected onto another lens. But then you can manipulate each mirror to merge the two mirrored images into one image, right? So you can take the blue image that's off a little bit from the red image and overlap them so that you get a single image without this dispersion. This is not necessary with any terrestrial observation. I've never ever seen, but the thing is, what's the point? The point is that this is just saying, hey, you made a terrestrial observation. This is caused by extreme refraction. This allows you to do this. But the extreme refraction condition would have other things that we'd observe. When there's extreme refraction to the astronomical bodies, we observe this red-blue freaking dispersion. We don't see it with terrestrial bodies ever.
Which are some photos of this red-blue? I can't seem to find this with planetary.
Yeah, I'll show you. Hold on.
I just Googled it. I Googled dispersion corrector telescope, and it showed them, and the AI's first response explained it exactly as Indio explained it. I go to Google Images, and they show thousands of examples before and after using the corrector.
That's okay. I just want to see it. I'm not
being a dick. I'm just saying, so it's quick and easy for anybody listening to also do this.
I apparently Googled the wrong thing. It took me into redshift and blueshift, which I don't think we're talking about here.
Well, the only reason I'm saying, because red and blue are at the different ends of the spectrum, of the visible spectrum.
I get that, yeah.
So they're going to appear the most separated. So there's dispersion with Saturn right there, right?
Yeah, I see that.
That's pretty easy to see. That's fucked up. Now, we observe this in regular lenses too, so we have lenses have to be corrected for this. And this is why this is the main reason we don't use refractor telescopes over a certain size, because we have a big thick glass lens, and we'd have to correct, like when it came out of the first thick ass lens, like say you have a fucking, what is it, a 10-inch lens at Mount Wilson or whatever the fuck it is. Okay. When the light comes out of the lens, you're gonna have a double red blue image, and then you're gonna have to recombine the image. But then you get, like, because you're going through a whole bunch of other lenses, the quality of your image starts getting degraded. So we get to like a maximum size, we're going to use what's called a refractor telescope. And then like after that, we use mirror telescopes where you don't have this problem because the light's being reflected, not refracted. So we do this, right? A lot of terrestrial observations, they make things called apochromatic telescopes. Dude, what are you doing? So So they make one of the long distance observations from Canada to called Bars de Crins or something. It's 200 and what is it off the top of my head? I can't remember. It's 253 miles, right? 412 kilometers. They use an apochromatic telescope. That means at the telescope itself, the telescope is corrected so that the telescope, because you could always say, hey, I took this picture. I see this, what do you call it? I see this dispersion. Someone can go, well, that's the camera. That's just a shitty camera. They have crappy chromatic aberration. But this particular picture has an apochromatic telescope. So it's specifically designed so that you won't have any chromatic aberration in your photographs. The photographs taken with this show that they're out there in the world. There is no chromatic aberration of any image of the shot, like 412 kilometer shot. Because often we do these, like I said, these long distance observations, and people go, hey, there's a refraction, extreme refraction, that they, all these things. And like, there's no actual evidence for any of it. That's the point. And the reason I even got alerted to this is because they did this test. They did a laser test. They used 3 lasers across the Hawaiian Islands. And they shot it from one Hawaiian island top to the other. And they were trying to measure turbulence. They shine the laser. They have one telescope. They pick up all 3 lasers in the telescope at the same time. Well, these lasers are all different wavelengths. And then someone did their master's thesis on it, and they modeled it all out, and they said, well, because refraction, this telescope is beyond the diffraction limit, this experiment should have never worked.
Right, so just to summarize.
Because each laser should have been separated by a total of 20 meters. But the telescope itself that they picked the light up in was only 4 meters wide. So how, if the light is separate, if there's refraction and the light's separated by 20 meters, how do they pick it up in the telescope that's only 3 meters wide at the same time and do measurements?
Right, so like, yeah, so why do we see full chromatic aberration like to red-blue with planetary objects, but not the sun?
Yeah, well, and in this laser test that I just mentioned, they didn't see it in that either, which was done by the Air Force and the University of Dayton and fucking Boeing and, like, you know what I mean?
Yeah.
It was like a giant fucking grant for them to do this test. They weren't looking for this. They were doing an experiment on something completely different. But a guy that was part of the experiment, right? So, like, he took place in the experiment because you need the research to get your master's, right? You need something to write your master's about. So he participated in the research, and then after he got the research, now he has his experimental data to write his master's. He writes his master's, and he did the model for refraction, right? Standard refraction. This is what we should see based upon the lasers we use. And this should not have worked based upon the lasers we use.
Oh, let me read that a second.
I'll post it in the chat. It's called the multi-wavelength laser. I'll just get it. Characterization of atmospheric turbulence effects over 149 kilometer propagation path using multi-wavelength lasers and beacons. So that was the experiment, and I'll give you the fucking master's thesis.
I'll be honest, I would love to sit here and read a full study. It's probably just going to be the abstract.
You don't have to read that, okay? The only thing you need to know about that is that they did it. The fact that they did it demonstrates there's no refraction. Because this experiment should not have happened. It should never have worked. Dude, if you have a 20-foot fucking pole, can you get it through a 3 fucking foot door? Without turning it sideways?
Yeah, you can turn it sideways. That's mad to say that.
You know what I mean? Like,
yeah. No, let me, like, I get you're asking a lot of questions. You've got to, like, give me a chance to read some of these things. But yeah, fair enough. It's, so there's a graph. There's a graph that shows this is how much distance between rays. Like, these are the distance between the beams that should have been if there was refraction. The telescope is wide, is narrower than this distance, but they measured in. So they took in all these lasers into the telescope at the same time, separated them in fiber optic cables, and measured the speckle pattern at the same time, which they shouldn't have been able to do if refraction exists the way Goldberg to say exists. There's no evidence it does. It's just something that's just repeated over and over. Wait, so refraction doesn't exist as globe Earth say it exists, is that what you just said?
Exactly. It doesn't exist the way that they think exists.
So how does how does it exist then? How does refraction exist? Because you've given me some examples of refraction.
It's more complex. It's way more complex. It's not deterministic. The fact of the matter is,
it just happens.
The air is not a continuous freaking medium, right? So there's pockets and bubbles and pockets of different changes of temperature, density, motion, you name it, right?
No one denies that. I mean, yeah, there's difference in pressure and temperature across.
Yeah, but it's not just horizontal. It's not just vertical. It's horizontal.
Oh, you think because the atmosphere continues up further than what we understand that goes?
Well, no. What I'm saying is horizontally, it's not one temperature.
Yeah, I get
so
it.
when they do these, when they do these,
lever.
when they model it, right? They use a spherically symmetric model where the temperature is the same at a certain elevation, all the way across the line of sight.
Everyone understands that temperature changes as you go up within altitude, though. I don't get what you're saying there when you say horizontal.
Yeah, that's not necessarily true. Temperature goes up for the first 1 kilometer, and then it starts going down. Yeah, this has been measured by like weather balloons and shit.
Temperature goes down as you go up. Okay, this is
not for the first kilometer.
I mean, I'll just give you an example. I walked,
the only difference is
I walked up Snowdon like 2 weeks ago, and it definitely got colder the further I went up, and that's about 1,000 meters.
Yeah, but was it windier too?
No, it's I get it's anecdotal, but the general rule from what I've always known is that roughly 100 meters is 1 degree change in temperature in a reduction. Wind difference aside, and it was fortunately not that windy of a day. It was quite good weather.
Well, that's anecdotal. I have it. I can show it to you.
No, my example is anecdotal, but from what I have always been taught and understood within science, like it isn't just quite as simple as temperature goes down as you go up. There are changes of that. From what I know, it then at a certain point starts to go up and then it goes back down again. That's from what I thought I knew, but I'm not gonna quote that as an expert there. But that was my understanding, was that it goes down and then back up again and then down again. But I could be wrong there.
Yeah. Hold on, I'm trying to find it. I haven't looked at this in a long time. I haven't even talked about this one. There's a guy who did a bunch of freaking.
Well, refraction throughout these. I mean,
he did a bunch of balloon flights, and it showed that the temperature actually goes up for the first kilometer, and then it starts going down.
Okay. I mean,
anyway, that's not the important part. The important part is
okay.
Well, that's not the important. The important part is that the say like I have a spot 6 feet off the ground, and then a spot a mile away. How the light travels through that is the temperature isn't going to be like it's 50 degrees at me and 51 degrees at them, and then just like this smooth gradient. There's going to be pockets of air, right? There's going to be this pocket could be freaking 10 degrees warmer than the pocket, right? It's almost like the way they describe it are like beer bubbles.
He's imperfect.
Bubbles in beer, right? So there's like bubbles in beer. That's like there's pockets of different air temperatures and density between you and any line of sight, and how large they are changes. They could be bubbles that are freaking half a kilometer in size. They could be tiny where they're like a meter in size, right? So every time the light passes through one of these pockets, right, it gets moved around, right? Refracted up or refracted down. Goes in, refracted up, comes out, refracted down. Goes in, refracted up, goes out, refracted down. And this will just happen. So why we see like the scintillation of the stars and shit shimmer around and things like that.
I get always see shimmer and light to the distance. It's flicker, yeah.
So this it's a complex phenomenon. It's not some simplified spherically symmetric model where shit just gets lifted up and down. It's way more complex than that.
Yeah, but that doesn't disagree with when we go back to our original point we were on about way earlier, where
it disagrees with the whole fucking gradient. It disagrees with the whole gradient of shit up crap because there is no gradient.
Gentlemen, sorry to interrupt, but
okay. So here's where we get to where we clearly you don't think there's a gradient of the atmosphere. Is that what you're saying? There's no gradient.
Look, there's not a uniform gradient. It's not like that. It's not how it really is.
All right, but I think we've got to the crux of the problem there, because the model works with a uniform gradient, from what I know.
Yeah, and that's why it's a model. The 1976 U.S. atmosphere model is pretty much what everybody uses. But that's just a model, but that's not how the world really is.
But then we've got to the source problem. So you say there's not a uniform gradient, and that's why it shouldn't make sense.
Yeah, it's not. You could have a gradient for the first like 100, say 400 meters away from me, and then the next 400 meters it's inverted, and then the next one there is none,
there's some differences. Fair enough. When we say uniform gradient, we're talking in a general term there. So when you look at pressures, when you go up in altitude, that those pressures are going to vary, but there's going to be a degree of error within those variations, right?
Yeah, but that's not the claim. The claim is the general rule is shit is being refracted over the horizon because it's a fucking gradient. There's no evidence for that.
You've lost it. There's no evidence for.
There's no evidence for that.
Observations and.
There's no evidence refraction in a fucking spherically symmetric atmosphere is curving shit up and lifting up over the horizon. There's no evidence for that shit. There isn't even a shred of evidence for it. Why? Well, let me give it to you. Okay. Has anyone ever observed this? You don't even have a model that actually predicts.
I've not done the science myself. But from what I've read, I wouldn't say there's no evidence on it. I mean, I can.
Well, I'd say. Well, from what I've read, I've seen that they admit there's no evidence for it.
I'd say Indio's been doing a. Hold on, I'd say Indio's been doing a pretty damn good job over the last hour explaining everything he says, backs it up, and post shit in the chat. And Andy, come on, you are assuming this should be the way, but you haven't really proven anything. Indio has.
Oh, he's posted some sources, and I'm asking some questions. That's fine.
No, I get it. I'm just saying that you got to think about it that way. Indio has been doing this like.
Oh, I don't deny for 1 second. He's just been doing a very good job of discussing this and explaining some things. Yeah.
Well, I mean,
really
why do you think? Let me ask you, Andy. Why do you even think it's the case that this happens? It isn't obviously based upon the academic literature that you've read and your extensive knowledge of it. So why do you believe that isn't meant to be an insult? It's only meant to point out that you have an idea in your head, but there's actually no evidence for the idea.
It's because the observations don't match the idea of us being on a ball.
Yeah, no. I mean, my idea of us being on a ball isn't just from one observation. It's from a multitude of different things that make sense with that model. So it's the point is the observations don't match us being on a ball of claimed dimensions. That's why these other things must be the case. But when we get to the things where I don't think that your observations match it, like you just seem to give the answer.
And then you can turn the observation right into proof of the globe, because that's how it must be if I live on a globe. It's this continuous fucking circular reasoning.
Oh no, it's like everything that I understand. So it's not. There's multiple points I can go.
That's a statement about you, dude. That's not a statement about reality. That's a statement about your own mind.
We'll talk about my own beliefs. Yeah, but I'm relating to this back to my own beliefs, so it would be about my own mind.
Well, think about what you did, Andy. Like, it's almost like you guys have golfers fucking memory. You posted Jaren's fucking whole fucking flashlight experiment in the chat, thinking it was evidence for a globe, but it was evidence against the globe.
No, I posted that really briefly.
Have you actually accepted that in your head yet? That was actually evidence against the globe. Because
I accept under the horizon. What's going on there? I admittedly said when I posted it, I've watched some videos and I don't have much of an understanding of them. At the same time, you told me to post the video, and I was like, I'm sure you guys all know the video, but yeah, I'll post it anyway. And you admittedly know more about it. I don't think from what you said, like, I get the fact that the reflection there. Oh, sorry. No.
You're not giving it, dude. You keep saying you've seen observations that match the globe, but none of your observations match the globe. And when they don't match, you bring up. I'm not making it personal. When I say you, it's the fucking royal you. So, you guys. Okay, all observations match the globe. Okay, here's one that don't. Oh, we have a hog explanation for that. Still matches the globe. Every observation, that's what T-Dub was saying, every observation will match the globe because you have a Band-Aid to make it match the globe, because you just add something. You're making it unfalsifiable. Like, what can falsify the globe, Andy? Like, tell me, what observation can we do? Where you can't add a Band-Aid, you can't add something at the end and say, well, the globe explains that it has some fucking widget.
Go into space and you can see
every fucking time, dude. Every single fucking time.
How is that every time?
Because it's not falsifiable then.
Right, but is the idea of, like, how can you falsify it? Well, you can go high enough up where you can see the whole thing. Oh, well, that's...
Yeah,
well, there you go there. Like,
it's not falsifiable. Well, that means it's not falsifiable.
Right.
So was the globe first proven, like when they first went to? Was the globe first proven when they went to space, or was it proven before that?
It was understood and believed before then. There were other elements.
Okay, so prior to Sputnik, right? Nobody could even falsify the globe. It wasn't even possible. So at least prior to Sputnik, the globe was a pseudoscience. Hold on, dude. So the globe prior to Sputnik, now Sputnik went to orbit or whatever, right? So prior to Sputnik, the globe was not falsifiable.
Yeah, so we talked about other methods today, how you could do it, and I get you said there are some inaccuracies within those.
I just said falsifiable.
Looking at planetary bodies and stuff like that would be the way that I would say.
Well, one second.
So if we saw square planets, would that prove the Earth's not a globe?
It would certainly question our understanding.
Oh, Jesus fucking Christ, dude! You're making me want to fucking drink.
It's like crazy. That'd be nuts, right? But we don't see square planets. So
how are these squares? We must be a square, dude.
Yeah. Would that not just question our whole understanding of physics and the fact that we never, ever, ever see that? Does that not say anything to you? Like,
Well, you see it in Star Trek, the Borg cube, man. Maybe it's just a fucking Borg cube.
exactly.
Hey, do you take over for a second, dude? I got to do.
Well, what about that huge-ass piece of whatever it was that they said passed by Earth there a few years ago? What'd they call it? Some Hawaiian name or something? It was, like, really misshapen and really long and not a sphere, right?
Yeah.
What happened there? What happened with physics there? Why didn't gravity kick in and turn that into a sphere, you know? But I wanted to ask you, right?
Well, let me answer the question. You asked me a question, and then you're moving on to something else. So let me just answer really quick. So what I know of this, I assume you're talking about a meteorite that's not in a perfect spherical sort of form, which
it's not as anything. It's just
because of the way they're formed. So meteorites aren't formed from where you have a massive amount of gas. That we talked about the protoplanet.
Yeah. How do you know that? How do you know that? Can you prove it?
What y'all doing?
Let me finish my answer. I get that I haven't stood there and watched this phenomenon, but on this model of them doing this, like
what model?
Meteorites,
What model?
Yeah,
what model?
Protoplanet model we discussed.
You have a working model?
Yes.
How about you put the ball with gas pressure inside the vacuum chamber?
Can I just finish my point, please?
What's it?
Of why? So meteorites on that are formed from other things, such as impacts between planetary bodies and stuff like that would form more jagged and distorted rock bodies.
You never saw that. It's a fairy tale story.
I haven't seen that.
But I wanted to ask you, Andy, because you said what would falsify the globe? Is this like being able to go to space and see it, right? Is this the standard that you have set for yourself?
I guess
I would only accept any claim about the nature of the shape of the Earth if I myself could go to space and see it. So that means nobody else's claim first-hand experience of that.
It's me.
Right. Yeah. So is that just applicable? What I'm asking is that just applicable to flat Earth, or will you accept somebody else's second-hand?
I would. So yeah.
Right.
So let's say the general consensus within science shifted to the fact that we were wrong all this time. The Earth is absolutely flat. All these models we had were entirely incorrect. New science completely disproves that. Here are many peer-reviewed studies, and the consensus within science shifted.
No, I'm not talking about that. We were putting that aside. It's just the standard that you gave for falsifying the globe, right? So
okay, I thought you were talking about what would shift my mind.
So because that would be looking at what it falsifies, right? As in. It would be falsifying one thing or another thing or a multitude of things, right? So that's the standard that you've set for yourself. I'm only going to accept, right, claims about the nature of the Earth, which I have first-hand experience of, by going to space far enough away from the Earth to see it, right? So you're not going to accept globe Earth, you're not going to accept flat Earth, you're not going to accept donut Earth or pyramid Earth or any other Earth unless you can get far enough away from it and see it for yourself, right?
No.
No. See, this is the problem.
Right.
That should be, if that's your standard for one thing, it should be a standard for all things, for all claims about the shape of the Earth.
But does everything else not work on this model that we live in today? I get you guys disagree with that model, but let's talk about GPS systems,
Go for it,
satellite
we are not living inside the model. And you talk about satellites. Yeah, what's your problem? We have a guy. He's a flat Earth guy, but the guy was a global. He went to Antarctica, and now he is working with a set of companies. One of those companies are working with microsatellites. Yeah, and they are using cameras with flat lenses. No more fisheye lens. So they are pointing down, and you see it's flat. Interesting. Isn't interesting talking about technology?
I don't get your point. Sorry.
And you want to talk about satellites? You want to talk about satellites? We have an ex-NASA technical that did work with satellites, and in his papers he had to account. He was doing programmation. He had to account a flat stationary Earth. Very interesting.
You have so there's one NASA technician who's come out and said the Earth is flat. Is that what you're saying?
No, he did work with satellites.
He worked with
satellites, yes. Yeah. And in his papers, he's saying that he has to account a flat stationary Earth.
Okay.
So it has to do the programmation according to a flat stationary Earth. Why is that?
So, but essentially, what you're saying is one guy that works in the industry has come out and said we
have more people that did work to NASA, and they are talking about flat Earth. Thank you.
Okay, is it many? Because I don't know many.
It is many. Also aircraft related with NASA.
Like aircraft pilots. Okay, related with NASA or just because general
NASA?
I mean, commercial aircraft pilots would surely be in on this as well, right?
No, it's NASA Origin.
Can I ask how many is enough? Is it 51%? Is it 50.1?
If 51% of all these people that work within the industries were saying that the Earth is flat, then hands down I would be like, well, this is really suspicious and questionable for me. Yeah. I would very much be questioning my own beliefs.
Well, hold on. You're broadening his example. His example were designers, creators, not users and people that just work on airplanes and stuff like no.
Mm.
The design.
And by the way, you've never communicated with a satellite in your entire life. You never will.
So when my GPS, Google Maps,
you're not communicating with the satellite. You're not communicating with. Do you think you're talking to the satellite?
I think it's talking is an incorrect term there. I think it's sending data.
Communicating. Are you communicating with the satellite?
Yes. Yeah, I think it's bouncing signals off the satellite.
What does your GPS say to it?
No, that's it's not giving individual data to it. It's sending it. It's getting measurement.
Yeah, so it's not communication.
Yeah. Although it's a very base element of communication. So from what I know, it's basically working out where it is using the time it takes to send.
Okay, when your girlfriend is screaming at you and not letting you talk, is that communication?
Dude, I'm on the internet at 9:30 on a Monday. I don't have a girlfriend.
I'm just saying, if we just screamed at you and didn't while you're muted, would you consider that communication?
Technically, yeah, sure. Why not? It's really bad.
No, not really, dude. You wouldn't consider that communication. It's not communicating with anything. It's passive beacon. Passive means you are just passively accepting a signal, and it doesn't use a globe either. So,
but it's two-way though, right? Because even if the basis gets back, no, but it gets back the time that it takes for that communication to get there. And
that's embedded in it.
But that's a two-way street. Like it wouldn't know that time if it didn't have a confirmation that came back to it, because otherwise, then how would it know that time?
Do you think your freaking phone is syncing up to atomic clocks, dude? Like what?
No, the atomic clock is on the satellite, from what I know. I don't think my phone has an atomic
clock. Yeah, but you need to be synced with it to know the time of flight, right?
No, my phone is synced with the time on Earth. That the satellite has the atomic clock. So there's a constant time that's being updated through internet that itself is based.
How did you sync with the satellite, your clock, dude, on your phone?
I just explained to you. My phone is synced through the internet to.
How did your phone do it?
Through a constant 5G signal, 4G signal, whatever signal it's getting through internet. Yeah, so there's an atomic clock on Earth measuring that. That updates many devices around it. Those devices communicate with the satellite. The satellite has the atomic clock. Those two differentials help work out the distance.
You don't know how it works. You're making shit up on the fly. Your phone
that's my base understanding of it. But yeah.
Yeah, your phone's using something called network time protocol. And we could say you have, I don't know what your phone service is. They're using their own freaking network times. It's not synced to anything. They might sync it to somebody, like someone upstream, their clocks. But whether it's synced to an atomic clock, like on a Windows computer, it automatically gets your time. Now, typically, the time will come from Microsoft. But you can actually set it so that it gets it from the atomic clock at the University of Colorado, or you can get the one at Lawrence Livermore Labs. So you can choose what network time protocol server that you access in the first place. Like, you're not syncing to atomic clocks. The time is in the message.
Right, again, but this doesn't differentiate too much from what I said. Okay, so fair enough.
But the funny thing is, it doesn't use a globe either. So that's the funny thing. The coordinate system of GPS isn't in latitude and longitude. It's converted to that. It's actually the actual raw data message is only the time of flight in what's called Earth Center, Earth Fixed Coordinates, which is actually a plane called up, down, and easting. Those are the three Cartesian coordinates that it uses.
How does it work if it's not a satellite? How does it calculate my position?
Because of time of flight uses trilateration.
So it just works from what time of flight from the signal of the.
Yeah, and it has it has something called a pseudo range.
Yeah, it does that as well to a certain amount of accuracy. That's what it calculates my position from when it can't get satellite.
Well, I doubt your phone ever used GPS. Your phone probably uses network location services.
But network location services are they have a really large degree of uncertainty to them, so it gives quite a vast area. It shows you.
How would you tell the uncertainty, dude? Like, oh my God, my GPS, I'm actually a meter off. You'd never know.
I mean,
if I fire up the GPS in my phone right now, it's going to show I'm not even inside the building I'm in.
Yeah, that's not. I mean, my GPS does, so I don't know what your GPS is saying.
Yeah,
but if
I'm just saying,
with satellites within the building that you're in, then it can show it.
You're not using a satellite, bro. You're using network location service.
Yeah. Okay. So yeah, when you're on a Wi-Fi within a building, and then it has it can use
cell phone network
within that cell phone network.
The cell phone network. The cell phone network. You're using the cell phone.
So explain one thing to me. When you're outside of where there's any cell phone network, you can still use GPS satellites. How does that work?
Well, if you have it turned on, then you'll use GPS.
Yes, so I can download my map, and I do this regularly because I go hiking in the wilderness where there's absolutely no signal. I can download the maps from Google, and I can use my GPS to accurately tell me exactly where I am within those locations. So how does that make sense there?
Yeah, because they have on-the-ground GPS transmitters. They're called differential GPS or WAS, or there's a whole bunch of other systems too. They broadcast this exact same signal.
So you're saying that the conspiracy goes so far where they're broadcasting
Not a
signals.
conspiracy.
Well, okay. So the lie goes so far where there's no actual like 4G, 5G signal in the wilderness of the UK. Out in the Lake District, the Snowdonia Mountains, the up in Scotland, where pretty much all of it gets no fucking signal.
They're sending think there's a ball in the way.
Let me finish my point, because like you're saying that in all those locations where when I go hiking there, I download the map and I track myself very accurately, and I can see this accurate because I have this map downloaded and it's within like a meter. It's very impressive of the path that I'm on. So in all of those locations, how is that telling me that I'm right there, right exactly where I am? Is it
Okay.
are the satellites, are the signals or maps?
Because radio signals, because the GPS signal travels a lot farther than you think, because there's no ball in the way.
Right. So really, my phone is getting signal, but it's telling me I'm not getting signal
From transmitters that are on the ground. Yes, it's getting signals from that.
Yeah. But
Not a cell phone tower, because a cell phone tower is a different band, right?
Okay.
So different bands have different penetration strengths in the air. Also, depending on the antenna, they also use different powers. Typically, things like cell phone telecommunications signals. GPS is like 2 point. Can't remember off the top of my head what frequency it is.
It doesn't use the same exact signal as the internet or the calls on your phone.
Yeah, it's a different frequency, man. It's a different chip. It's a different frequency. It's completely separate.
And Andy, he did say it was ground-based. You just didn't listen to him. He repeated himself twice.
No, I got the idea. I get the idea that what you're, because of course from your idea it has to be ground-based. I'm not denying that you're saying that. The sort of bewilderment that I have is that out in all these places where there's, I can be in a location where I'm just literally just surrounded by large mountain bodies that are blocking out any signal. I have zero phone signal, literally no data. I can't even make emergency calls, which is run off 3G networks. But I can get GPS data. It connects to, and it can, on my drone, it tells me how many.
So look, check this out.
So you're saying that this is taking place on a different.
No, you heard what he said. You heard what he said. It's like I hate when you say something and he's like, so you're saying, yeah, that's what the fuck he's saying. Like, chop the conversation time down a little further. Second of all, it's like I've been listening for a minute, and it's like, it's like they never actually claim. They just have incredulity, and then they're like, are you making a claim as to how this is working? Are you saying that because you live on a ball, this GPS is working in the way that you're saying it does? Or are you just here to be like, I'm saying I don't know how else this could happen, because if I got mountains around me, it can't be what you're saying it is, and I'm not necessarily making a claim, but I am saying
no, I'm making quite a claim. Yeah, no,
so make the claim. So make the claim.
Because this claim works everywhere on Earth.
So make the claim. Let me hear it. Make the claim.
You can tell me to make the claim. I'm trying to talk. So the claim is that when I'm in place, when I have absolutely no communication with satellite, with anything other than satellite. So this can be in the middle of the ocean. This can be, when I'm on a plane flying to somewhere. This can be when I'm in the middle of a wilderness, for example, Scotland or any other place. I have a location data on my phone that tells me exactly, very accurately, where I am. And there's no other way it can do that from communicating with satellites.
It's a very vague claim. That's a very vague claim.
No, it's fine. But is that all you're saying?
I mean, that's the basis of the claim.
Well, okay. So there are things above the earth. So, do you have anything further to that?
Okay, so you're saying there aren't things, or you admit that there are those satellites?
No, I'm asking you, right? Aren't I? Isn't it your claim? I said,
very basis. I mean, sure, we can go into more detail. They orbit the Earth, but yeah, my base claim here, and it's
okay. Orbit is in a circle, or what do you mean exactly?
Yeah, orbit would be a circle. Yeah,
around a globe, you mean?
Yeah.
So that's the claim. All right. How do you know that?
Well, that's very part of the claim. But we're talking about how they give me information compared to where I am on Earth. I'm not getting into the detatel of how the orbital mechanics.
You made huge leaps of logic. Huge.
Okay.
I go to the woods. I download a map.
Back to the base claim.
I saw a little crosshair, and I can't make a phone call. Therefore, there's satellites in space orbiting the fucking Earth, and I'm on a ball.
Well, it's not just I'm in the wilderness. Like, it's literally the middle of the ocean. Nothing else around.
When have you done that?
Presumably.
I've done it on a cruise ship. I've done it on a plane.
And you're presuming. You're assuming. It's a presupposition that there's nothing else could possibly communicate with your little handheld phone. That's what you're relying on. That's why I said it's a vague claim. Because you're not listing any locations.
the devices that are on these bodies that I'm on, the plane, or the cruise ship, or maybe there's devices out here in the wilderness that are falsely telling me, or not falsely, sorry, but telling me where I am from other devices and then masking how they're doing that.
Do you understand how that works though? When you download the map, do you understand how the equipment that you have, let's say your phone, do you understand that inside of it, like if your GPS part of your phone was broken, it would still use the accelerometer, the gyroscope, the magnetometer, or magnetometer.
I get how those other things, but they're not going to.
But here's the point, though. Here's the point. When you take your phone, okay, and you download the map, and you have a signal, and you're like, okay, and it's using the towers to triangulate your position on the ground, okay? Then let's say you break the GPS part of it. You're like, okay, now I'm going to be lost. No, as long as you downloaded the map, and you can even lose your internet signal and your cell signal, but it knows if you take 100 steps to the left, it's a mathematical thing in the app, and it's using the phone sensors. And in the map that's on your phone, it will move you. It will know that you will know that. It's not going to be exactly precise because they do say that it's still off a little, but it's not using in this junction. It's not. I'm saying it's not necessarily using the satellite.
Hold on. Just to clarify, it's called inertial navigation.
Right.
I get the inertial navigation.
It calculates how far you move based upon the accelerometers in your.
Yes, right. Yes. So that has so as you move further, right, that's going to have a knock-on effect of the inaccuracies because you give one inaccuracy and then that's going to multiply every time with that inaccuracy. So if you want to use that for something like a missile, all right, which goes in a very sort of straight trajectory over time and also takes information from other data, it can be a very effective tool for when the other data is unavailable to it. But if you're going to use that for a phone, going through a wilderness where you're not going to get any communication with other devices for a long time, it's going to be a terrible thing because those little small inaccuracies are going to multiply over time into such a high magnitude where that data is just completely unusable. But that's exactly what we don't see when you use GPS data. I can be in the wilderness for 1-2 days. Let's say I'm doing Mount Sully in Scotland, for example, where you have to basically wild camp to get to it because it's so far away from any road even. Like the GPS data is accurate to a meter while I'm at the top of that mountain, and even when I get to the bottom of it and I'm in the valley again, it's accurate to within a meter. It's so perfectly accurate. So that just doesn't make sense from what you're saying there.
So do you think you'd be able to get that with the ground-based system? Does it have to be?
I think if you set up a network of ground-based systems around the globe in every wilderness and everywhere, then you could give someone that system to do that. Absolutely. I think let me finish my point. I think the idea that will be done to mask the fact that it's getting done from satellites is a ridiculous claim.
It's already done. I already told you. It's called differential GPS, dude. It's already done.
So all these ground masts are set up around the globe. And
you keep saying
they had a system called differential GPS, which is undisputedly ground-based GPS that will appear on your phone as a satellite and will give you your location.
You're saying this is placed
all over the place. They're all over America. I know that.
Right, you're right. But you get the GPS works everywhere. It's not. So, for example, let me give you one example.
I think you're making that up, Andy.
I recently went to Morocco and climbed Mount Toubkal.
Once is not a trend.
So I was going to make my point anyway.
No, it's not. Once it's not a trend. I know where I live. GPS is fucked up, dude. Where I live, it don't work very well.
That's fine for you. I've never had. Sorry, someone's hot micing me. I can hear my voice going through. Which I love it to a certain extent. It's a bit off-putting.
Hey, Andy, why don't you just Google what differential GPS is? And the definitions, hold on, just shut up. It says transmits correctional signals to GPS navigation equipment on board vessels. So you are of the belief, the assumption, that GPS is the shit when differential GPS corrects the navigational equipment.
Here's what I think's happening here. I think there's a system, the GPS that works, and you're being like, no, there's something else. And that's differential GPS. And just because that exists too, it doesn't disprove anything that I've said. Differential GPS isn't going to explain. You can use this as an addition to the GPS system, and you can use it to make readings more accurate, and that's absolutely fine. I have no doubt that it does within that GPS system. But it doesn't disprove anything that I've said. Differential GPS isn't set up worldwide. Okay, there'll be no sense of that. It just doesn't, from the basis of it. That's a crazy.
But you were just making the primary argument that it was stacked tolerances and little discrepancies over another discrepancy makes it inaccurate, where in fact it makes it GPS accurate.
No, you really misunderstand my two arguments there. So if you're working, firstly, the initial argument was using gyro data of a phone, and that's where I specifically said, if you're going to use gyro data that has an inherent inaccuracy over a long period of time, those inherent inaccuracies are going to multiply to such an inaccuracy where there's just no point using that data. So
Yeah,
if you're using differential GPS, which has a constant communication with some other source, then that inherent accuracy or that inaccuracy from whatever you get from GPS or differential GPS would just keep to what it wouldn't multiply. It's just its own inaccuracy. So like that's not what I was saying.
I'm just trying to understand one thing. When Indio told you about that the GPS signal that we can have from ground-based towers or transmitters, yeah, it's really that, because it will be easy to understand if you just distinguish between the two signals, the GPS signal and the GSM signal. They are not the same. Yeah, even if they use the same tower, you can have both transmitters and receivers in the same tower, GSM and GPS. You just have to know the GSM, you won't have that data or signal on your mobile phone when you are in a dead zone, because the GSM signal will just cover a short distance, like few kilometers, 5 kilometers for 4G or 3G. So it's just small distances, while GPS is able to cover huge, enormous distances
everywhere,
by thousands of miles. By thousands of miles, yeah.
Pretty much everywhere. I'm sure you can go to some. I don't know how GPS works if you get to the Arctic and the Antarctic. I know that satellites around there. There's going to be less due to the orbit of them, but effectively everywhere that I've been, and this, like I said, multiple places. But most recently, around 6 months ago, in Morocco, doing Mount Toubkal, where there is absolutely no phone signal. You're up in the Atlas Mountains there. GPS works perfectly, absolutely perfectly.
It doesn't need to surprise you, because that GPS signal is able to cover hundreds and thousands of miles. So it's so easy to understand that, yeah, you can, if you are on a flat plane, let's say you are in the center of the north, the towers are, the nearest one is in Svalbard, the next one is in Alaska, and the other one is in Russia or something like that. Yeah, you can have triangulation with those towers, even if they are hundreds of miles away from you, because you are using not cell phone signal, not GSM signal, but GPS signal, L5 bands that are 1,000 something hertz.
Yeah. Okay. So it's using such a high frequency that it's communicating with places that are all around the globe. Is essentially what you're saying. That's how that works.
Correct. If you have some questions about ocean,
and when I am in the valley and I have no clear sight, and by the way, let's keep in mind that high frequencies don't transmit well through solid bodies. Low frequencies do, because of the high wavelength. You could potentially say, look, it's such a low wavelength that it manages to travel over that body. But GPS still works in valleys and places where you only have sight of the sky. How does that make sense?
Yeah, because GPS and those cell towers, they are not on low elevation. You can find them on low elevation only in ocean on some buoys.
That mathematically doesn't make sense. They would have to be so high that they're in orbit. I mean, I'm talking when I'm in a valley, there are mountains on either side of me, climbing up, thousands of meters on the left and the right. I'm in a valley. I can just see sky. And if I was to have a direct view to anything there, you're not even talking in orbit. You understand the maths of this, right? These things to my left, to my right, to my front, to my back, climbing up at a steep degree. How does that make sense?
Which won't make sense.
Well, it has to be in orbit, number one, on a globe, which we know it's measured and practically used as an oriented horizontal plane. And two, your claim also includes rotation of Earth, and then the satellite would, assuming, geostationary, meaning orbiting. No, what I'm saying is this would have to be the case, and we don't have any proof that the Earth is spinning, or that it's a globe. No, it is correct that we don't have proof that the Earth is spinning or is a globe. In fact, we have evidence of the contrary. So,
you said that what I inserted would have geosynchronous, which satellites aren't. GPS satellites, there are geosynchronous satellites, but most satellites, you have communication with them over short amount of time, but you're constantly checking with different satellites. They know their position, they know their exact time. That's not how GPS works.
Yeah, just like my friend Mimas used to say.
That's not true, I think. Sorry.
You think all GPS satellites are geosynchronous?
It's odd that when he's driving through parts of
geostationary, same thing, but it's
especially going over. Oh, yeah, definitely. So let me go ahead and do that first, and then let me unimpeded say what I want to say. So just like my friend Meme used to say, he'd be driving through some parts, some places, and would get like no signal. He used to test the GPS and is getting no signal at all. Just communication just drops.